All right, howdy everybody. What I have planned for today was to review Project 1 deliverables and go over the rubric, introduce you to something called Critique.io. I sent you an announcement that would be using Critique.io, and then I sent you an email to the same email that you used in your midterm, when you submitted your midterm. So that will supply a link to Critique, and then the project and the rubric is documented there, and we'll go through how to use Critique to it today as well. All right, check your spam. Hope it may have gone to your spam. If you could please send me an email to the email that you would like me to use. I don't know if you guys are like me. I've got like 4 different emails, and maybe an email that you didn't submit for multiple choice.
Okay, sounds good.
Okay, thank you. All right, so let's see, where was I at? Okay, let's start off with giving an overview of the project. We'll just jump right into it, okay? Let me share my screen. Share screen 2, and I'll walk you guys through the project. All right, can everybody see my screen today? I got my slides up. Oh, this is not the one I want to use. I want to use a different one. Oh yeah, this is. Let's delete that one. Okay. All right, so there's 4 equally weighted components of this project. First section I call integration. There's a section on program accuracy and reusability. And there's one on programming styles and graphs. And then finally, comments. Now notice that the accuracy and the results of this are really just kind of 1/4 of the project. It's all about how you integrate this, you document it, and then your programming style. So that's something to appreciate, is that you can do really well and not necessarily get the exact right answer, okay? All right, what do I mean by integration? So this is what's in the rubric. It's word for word the same thing. So I'm going to review this with you real quick, see if there's any questions with this group. My plan for today was to go over this project and then break you guys up into some breakout rooms, and you could develop the flow chart as a team, okay? So the goal of this assignment is to integrate the appropriate functions and coding into one project and document the project so others can understand your application. The program should be written so another data set from another animal could be analyzed. The data that I've given you is one animal, where it's got 163 files. We collected data from about 20 animals. So, for example, I should be able to just input another on your test code or your code that you submit. I should be able to take another animal, put the data in, and give the file numbers, and it should just work. Okay. Okay, you should submit a main program, an extra module, another file that includes all of your functions. So it's a total of 2 files. The main program and modules should be in one folder and compressed, okay? So when you go to do your peer reviews on this, you'll download the one folder with one zip file with the 2 folders, put it in one folder, and it should work. Now you may, what I do is I just keep the data in my download file, and then make sure that the data the path to that folder is the same. And you may have to hunt around and exactly figure out how to pass the data from your computer into your partners or the peer reviewers' code. That should be pretty straightforward. It's one line of code that you can change. You should also submit a screen capture of your flow chart and pseudocode, which you will do as a team today. So you can modify it, edit it, and all those kind of things, but you can do that today, okay? For each function, create help similar to what is displayed with built-in functions. There's a high-level description, and the variable and parameters are described. Okay, so that is kind of weighted by a factor of 1. The second of the 4 different components is program accuracy and usability. So you will load in files data 6 through data 60, and you will calculate the mean and standard deviation of the SpO2 periods for the low and high activity periods. So I'd like you to print to the console the total number of low activity and high activity periods. So that's just two print statements, or one print statement with both of those. And then the definition of a low activity period is a 10-second or greater window with the accelerometer magnitude within the plus or minus 10% range of the mean magnitude. The high activity periods are anything outside of that. So you'll notice that your assignments have already been very similar to the project. You will have to integrate it all into one project is the goal, okay? And the second thing here is to print to console for all the low activity periods, the mean and standard deviation of the heart rate and SpO2. So just take the low activity periods and output the mean and standard deviation. The result is one mean and one standard deviation for the heart rate, and then one mean and one value and one standard deviation for the SpO2 for all the low activity periods across the entire data set. All right, I'm going to stop and see if there's any questions. You guys could send a chat if you see any questions along the way, okay? Okay, I have to read this pretty close, let it set in. All right, there are other elements of the program accuracy and reusability. Graph 1. For the low activity periods, plot the mean and standard deviation for the heart rate using an error bar plot. The error bars are for the standard deviation from the mean. For the x-axis, use a time series of 4-hour periods per day. The final plot will cover several days, okay? And then for graph 2, for the low activity periods, plot the mean and standard deviation of SO2 using an error bar plot, and so forth. Final plot may cover several days. For the x-axis, use time and, okay, basically it looks like I've repeated. Graph 1 and graph 2 seem to be the same. What did I make a mistake here? Yeah, it's the same. Both of them for the activity. So I'll change this on the deliverables. Oh, the second one is the SpO2. Okay, be real clear. The second graph is the SpO2. The first graph is the heart rate. So there are 2 graphs. Confused myself there. And then the final point here is the code is reusable for another data set. So I've asked you to analyze 6 through 60, but you may also input 30 through 70 or 61 through 130. And please appreciate that the hard-coded constants really makes it hard for someone to reuse your code in the future. So look for hard-coded constants and make them into variables. Okay, the third element is programming style and graphs. Descriptive, intuitive variable names, use Python modules and Python syntax, intervals to minimize unnecessary loops. So did it have good performance? Did it take 10 minutes to run, or could it run in about 20 seconds? I think some people get this thing to run in just a few seconds, okay? And intuitive figures and plots, axis labels, graph titles, important information is displayed. All right, so here are the constants and equations that you should be aware of, right? There's the sampling rate, you guys know that. Here's how to calculate the magnitude of the acceleration, the definition of low and high activity periods. And you might want to appreciate that the data collected was approximately every 40 minutes for 40 seconds from 8 p.m. to 6 a.m. So there was no data collected from 7 a.m. to 8 p.m. basically. We have not talked a lot about this in class to date, but there is 1 or 2 videos on how to calculate the SpO2. And there's an equation called the ratio of ratios used in SpO2 calculations. And it's the AC red over the DC red divided by the ACIR over DCIR. Those terms are defined in a video over the theory of SpO2. Very important note is that take the inverse of R. Red and IR channels are swapped in a CSV file. So every time we've been saying red, it was actually the IR signal. Okay. So the equation for SpO2 is SpO2 equal 129 minus R, which is the ratio of ratio, times 32. Okay, so that was defined through a collection of experimental data, and so that is the equation for SpO2. So to calculate the SpO2, you need to know these definitions. So what is an AC component? That's the component, the difference between the peak and the trough. There's the heart rate. You can think of that as the difference with the beats per minute, calculated using the peak values of PPG signal. The DC component is the distance from the trough to the baseline. And this is the red channel of the data, for example, or it could be the infrared or IR channel of the data. This is mislabeled. This says time in milliseconds. It's really time in 10 milliseconds because of data collection. So I made a little mistake there. I'll correct that before I publish it. All right, so the really important thing here is that definitions that are used to be able to create the project. Here's an example of what the SpO2 graph would look like. It's graphed every 4 hours, kind of got an interesting x-axis here. It's every 4 hours. Here, this one started out with a really tight standard deviation and a high mean, about 100. That's 100% SpO2. And you may get values greater than 100%. It's not physiologically possible, but given the equation and the data that we have, you might get a value above 100%. Notice this one has a very wide standard deviation. This one has a wide, super wide. They actually tend to get wider as the time goes along because the sensors started to fall off the ears of the animals. So got a lot of motion artifact and a lot of artifacts out here. Right, interesting enough, and here is a really tight mean and standard deviation, for example, for these two dates, for these two 4-hour periods. Okay, so that was, all this was done for just the low activity period. So you're doing 4-hour intervals, calculate the SpO2, mean and standard deviation, plot that for every 4 hours for both the SpO2 and heart rate. So heart rate looks similar to this, but has a different y-axis. Code comments. Sections of your code are intuitively separated and commented for maximum readability. I have distributed something called Codebook, which is a handout. I would like you to use that as a guide for how to make comments on this modular code. And so you will be kind of graded on how good your comments are and how modular the code is. Avoid using comments on every line. You can over comment, which is distracting, right? And I'll stop there and then I'll show you a couple of things here. Probably should show you, where is it? This one? Maybe it's this one. Yeah, so here's the pulse oximetry theory of operation, video on that. A bunch of background reading material so you can understand the biomedical elements of this. Here's the best practices on commenting and organizing code. You can go there. Here is the commenting code handbook, and it gives you a high-level overview of how to do the commenting and some rules of thumb. Okay, so that's what that is for. All right, I see somebody might have a chat. Let's see. I'm going to upload this project overview in Hints, Victoria. No worries. And you'll have the video recorded as well. Okay, let's see. The other thing that I wanted to show you was critique. Okay, so this is the tool we're going to use to do the grading. So the exact the same rubric that I just showed you is documented in critique, okay? Now, how critique works is you will submit your code, and I'm going to grade several of these, and then you will grade 3 of these. And so your grading as compared to my grading, also compared to the covariance, which is somebody else that graded to my grade, how close they were, and then how your grading agreed with how somebody else's grade agreed with my grade, right? So there's different levels of this. It's all built up into an equation to give you a score of how well you grade this. So you should grade this as if you're really trying to mimic in the way that I would grade it. Okay, so the midterm is probably your example of how I would grade. So you had really good feedback on that because I graded every one of them and I gave feedback to you. So you need to grade this as if you just can't give the high score to everybody and be done with it, right? You have to put effort into grading it properly is the message. Okay, let's see. So you will submit, you'll get 3 anonymous grades. You'll be given the rubric and how to score it. Let me see if I can find that real quick. Where is this at? Okay, so a few people have already dialed into this. Edit activity rubric here. Here's the rubric. So there's the four grading components, and I can check in on the full rubric. And this says, okay, for integration, there is actually 8 levels. Level 0 is that you didn't submit, okay? And then level 7 is student has organized code using input sections and functions into a modular design that is logical, easy to understand, easy to troubleshoot. And then variance of that grading level, okay? So there is a level from 0 to 7, or 0 to 5 to 4, in this case, the last one here, or code comments. And each of those are weighted by a factor of 1. So they're equally weighted, okay? And so you can look at the details for the rubric to understand exactly how to grade somebody, okay? All right, so I'm going to stop there. And so I think that's a pretty good process that we'll be using. And there's some learning exercises of this. You'll get to look at somebody else's code, see how they write code, learn from their code. And you'll then, the final stage of this is that you'll get to give any feedback to the reviewer. And so keep your first reviews very positive, give positive feedback, compliment what they did well, and give some constructive, critical feedback on how they could improve, okay? And your write-up, basically, the person who gets the write-up and the grade then will review and give feedback to your feedback, okay? So there's several elements to this process. All right, we'll go through it together. This is the first time I've used critique. I have used Perceptive, which is very similar. This seems to be maybe a little bit more intuitive layout. So I've decided to try that for this semester to see if I want to use it in the future. All right, I think I'll stop there and see if there's any questions. I think I've reviewed everything I wanted to today. I could go back and I could look at this document here, which is the coding handbook. This is very self-explanatory. The greens are kind of what you should do. The reds are kind of insufficient and not properly using good commenting style for your source code, okay? All right, I'm gonna stop there and see if there's any questions, and then we'll just break out into the breakout rooms and you can review the rubric and start to work as a team on the flowchart for this project, okay? Are you guys ready to go to a breakout room? we only have 1, 2, 3, 4, 5